Hi, I'm Richard Kiles, Principal Consultant at General Data Tech. I wanted to take a minute and go over containers in a little bit more detail, as well as identify some of the key terms that we use when we start talking about containers, specifically around Docker, and also show the difference between an instance and an actual running container. So just to level set on some common terms, a Docker image is the actual packaged application itself. So in a previous video, we talked about the difference between virtual machines and containers, and we identified the fact that containers are really packaged applications. It's not the same thing as a virtual machine that's a virtualized hardware platform that runs an entire operating system. It's merely an application with some system files that it needs to run. So a Docker image, like I said before, is that immutable or that unedited packaged application. When that packaged application is launched and is a running instance of that Docker image, that's when we refer to it as a Docker container. So that's the main difference. A container is the point in time running instance of that Docker image. Now we manage our images and containers using the Docker engine. So the Docker engine is that core application that actually launches and runs the containers themselves. And we interact with that Docker engine through the Docker client. And that can be the CLI client, it might be a GUI, it might be a management or an orchestration system like Docker Data Center or OpenShift that's interacting with the Docker engine itself. Finally, we have the registry service, and the registry service functions kind of like a RPM repo or like an app store. It's basically a distribution service for Docker images. This might be something that's public, that's out on the internet like Docker Hub, or it could be something that's private within your own data center running as a secured or a trusted registry service inside your own environment. So a Docker container is made up of one or more base images. So every time we add a new application or we make a change to an underlying image, we actually create a new image. And that image is created using the Union file system. We'll talk about that in a little bit more depth here in a moment. But just know that that container, the writable point in time running instance of a Docker image, is built upon multiple different images or layers. So we always start with a base image, and this could be anything from Ubuntu or a CentOS latest version, or even an application like MySQL. If it's a pre-built image, we use that as our base image for our application. Now these images are typically very sparse. As I mentioned before, we only need the core system and libraries to launch and run our application in those underlying base images. So they can range from anywhere from 100 to a couple hundred megs all the way down to 1 or 2 megs in the case of like BusyBox or Alpine Linux. And we build additional layers on top of that when we add our applications using that Union file system. Typically that could be either using AUFS or we might be using Device Mapper to manage those different layers depending on the host operating system that you're running. So we normally create these instances or these images using a Docker file. While you can go in and create your own container, make changes, and then save that as a news-based image, it's usually a best practice to go ahead and create those using a Docker file. Here's an example of a very basic Docker file. Essentially what we're doing is we're specifying which base image we want to use. We're adding some metadata to it. In this case, I'm saying that I'm now the new maintainer of this image. And then we do a run statement. And the run statement's basically pre-configured the image. So we can run different applications, we can make text files, we can use sed to make changes to text files if we wanted to. And then we have our command statement. The command statement specifies the default action that we want to have take place on this container whenever it's launched if we don't pass any other variables to it. Well, I'll show you that here in just a moment. So let's actually take a look at how we build an image from a Docker file. Let's make a new directory. We'll call this my app. We'll cd into the my app directory. And now we'll create a new file called a Docker file. So I'm going to use VI, but you can really use whatever editor you want. VI Docker file. First thing I'm going to do is add my from statement. I'm going to specify the base image I want to use. So we're going to use Ubuntu latest. The latest is the tag that we're referencing. I'll show you how labels and tags work here in a moment. Now I'm going to add some metadata in, so we're going to say maintainer is going to be rkyles@gdt.com. Now we're going to add our run statement. So run, we're going to echo. Let's do a hi. Better yet, let's do hello world. Hello world. And we're going to append that to a new file called test.txt. Now I do realize we're running a Linux system here, so I don't need the .txt extension, but we're going to do it just to make it easy. And now we're going to do our command statement. So let's do a cmd, and we are going to cat our test.txt file. All right, so let's go ahead and build this. So we can do a docker build -t, and this is where we specify our name and our tags, our labels. And I'm going to call this my app. And then we would reference our Docker file. Now I'm actually running this from the same directory where my Docker file is at. So by default, Docker will just go ahead and look in this directory. As long as I put a period at the end of that statement, it will look in this directory for a file called Docker file. And it successfully built our new image. Now you can see that it's actually adding new layers, which we're referencing here, each time we add a new command. We'll see more about this in just a moment. Let's go ahead and run a container based off of our new image. Docker run -it, and that means interactive pseudo terminal. And I'm going to specify my app. And I'm not going to add any additional commands to this, so it should just run our base command that we added earlier in our Docker file. And there it is, hello world. Now if we want more information about this Docker image, we can simply do a docker inspect my app. Now there's a lot of information in here, but we can see when it was created. We can also see the commands that we're passing through. And we can also see the maintainer information I added earlier. So it shows me as the new author, and even shows the Docker version that I used to create this. Now here we can see our base image, which was our Ubuntu image, and then the additional layers that were added on based on the commands that we issued through our Docker file. So let's actually go in and make a change to our Docker file now. So vi Docker file. I'm going to add a new statement in here. I'm going to add a new run command, and we're going to do a apt-get update as well as an apt-get install -y, and let's specify iputils-ping. Now before we build this out, let's actually run a ping command and see what happens. Let's do a docker run -it my app, and we are going to specify ping-c5, so 5 count, on www.google.com. As you can see, we received an error because our base Ubuntu image does not contain the ping utility. Remember, we don't want any additional services or applications that we don't specifically need for our applications. Therefore, the ping utility was not included with our base image. Let's go ahead and clear that out, and let's build our new image based on the changes that we made to our Docker file. So we'll do another build, docker build-t. We're going to call this my app again. However, we're going to make a change, and we're going to apply a new label to this. And we're going to say ping. Now that can be arbitrary, but I'm just putting ping in there just to make it a reference point for us. and once again, dot. Now, as you can see, there's some additional things that are happening this time around. We still have our base Ubuntu image. Now, we also have our maintainer item that we added from before. However, if you'll notice, it said, we'll scroll back up here, you will notice that it says using cache. That means that we already had that file system or that layer on our system, so we didn't have to rebuild that. Same way for our original run command. We are still referencing that same layer. Now we're creating a new layer when we do our apt-get update and the install of our ping utility. And you can see that happening through here. Once that's done, our build has been successfully completed. Now if I do a Docker images to show all the images on my system, you can see I have two My Apps. I have the latest, which was the original one that we built, but now I have a new tag that says ping. And you can see that this was created just 34 seconds ago. Also notice the difference in our size. So let's do a Docker run-it my app. And now I'm going to specify the ping tag. We're going to run ping-c5 www.google.com. And now we get a response. However, if we go back and remove the ping statement and simply use my app, which defaults to the latest tag, you'll see that the ping utility is not installed on that image. And that's because the ping utility actually runs in a different layer of the file system. If you'd like more information around Docker files and to see examples, you can reference the two links that I have below. So as you can see, we create a new union file system layer each time we make a change to one of those base images. This is done by using what's called copy on write. So every time we add a new file or make a change to the contents of the underlying images, we create a new layer. If you're a developer, you can think of this as branches within Git. Or if you're an administrator and you're used to storage systems such as NetApp, then you can also think of this as snapshotting within a storage system. Now, the type of copies that are made depends on the underlying host that you're running the containers on. If you're on a Debian-based system like Ubuntu, then you're probably using something like AUFS. And AUFS is the union file system that's used to create and manage those layers. If you're running on a RHEL variant like CentOS or Fedora, then you're using what's called Device Mapper. Device Mapper is a common utility that's been in RHEL-based systems for quite some time. However, instead of using AUFS like Debian systems, they're using Device Mapper to manage those file system layers. The big difference between the two is AUFS is based on a file change. So every time you add a new file, it creates a copy of that file within that new file system. If you're using Device Mapper, it's block-based, so you're updating and modifying blocks within the underlying system. It's also important to note that runtime-specific layers, so anything that has been changed within the container, remember a container is the running instance of the image, so anything that's modified within the container while it's running is automatically deleted whenever that container is terminated. That's why we have to have alternative solutions if we want to persist data after a container is removed. And that brings us to data volume containers, or DVCs. That's what we utilize to provide persistent storage in a typical Docker environment. That's why you'll often hear people talk about persistent data or persistent storage when we reference containers. And that can be solved by a couple of different solutions. One is to use data volume containers. The other is to use plugins for additional third-party products, such as Flocker. So let's take a look at DVCs. DVCs give us a simplistic way of creating persistent volumes or persistent data within a container. And essentially what we do is we launch another container that's specific to a DVC. And that then shares a volume with our containers. So data volume containers expose volumes to other containers. Now these volumes could be a path directly residing on the host, or it can be a volume that's created within the container itself. We can even share these across different running containers on the same host. It's important to note that DVCs do not run additional applications. They simply provide one thing, and that's a volume. So let's look at how we would create a DVC. Here's an example that we're going to use to create a new MySQL container and then connect that to a backend DVC. We're going to use Docker create, and then we're going to specify a name of MySQL data for the running container. The volume command identifies the volume that we're going to be sharing. So within our MySQL data container, we're going to create a new folder inside of varlib, and we're going to call it MySQL. And then we're going to specify the BusyBox image that we're going to launch this container from. Now let's create our SQL container. It's important to note some of the additional attributes that we have running within this container. Specifically, we're going to do a Docker run. We're going to use interactive terminal so we can actually see what's happening. You could also replace this with a -d if you wanted to run it detached in the background. We're going to specify a name for this running container called MySQL 5.6 because we're using the 5.6 version of MySQL. And then we're specifying some environment variables such as MySQL root password, MySQL database, this will be the actual name of the database that we're going to be using, a MySQL user called test user, and then the test user's password. Lastly, we're going to specify another volume command that says volumes from, and we're going to use the volume that's being shared from the MySQL data container that we created in our previous step. Lastly, we're using the MySQL image running version 5.6. As you can see, MySQL successfully instantiated the database and is now running on port 3306. And we're utilizing the backend storage from our DVC. So this takes us through the process of creating new images, running containers from them, as well as creating persistent storage for other systems. I hope you've enjoyed this time, and if you have any questions, please feel free to reach out to me at rkyles@gdt.com. Thank you.